Just checking whether you can hear me now. Let me check myself. Let me check myself. Okay, that sounds good to me. My setup is weird, as you know. Okay, so welcome back, everybody. Oh, sorry, as mentioned 2 weeks ago, I will not. Oh, I didn't stream last week. Because I was on vacation. But now let's get back to Project Euler again. I don't actually know what the last problem we had was. Something with pentagon numbers, and this time is again pentagon numbers. But I think we didn't use hexagonal numbers before. We used triangular numbers before, but that's about it. So we have this time the formula, and it can be verified that they are sometimes the same as for triangular number 285 is the same as pentagonal number 165, hexagonal number 143. And we want to find the next one. So let's do that. I use version 1.5 of Julia now. Just because I can. No, because it was released. Oh wait. Where did I save this? Wait, this seems to be wrong. Oh, def. I think it was released 2 days ago or stuff like that, and I didn't use it for Project Euler yet. No, I don't want to. Damn it. Where do I have this? No. Damn. Okay. It's on GitHub. So let me get it from GitHub. As you noticed, I'm even more unprepared than usual. I think this should work. That's just the package I use for downloading my stuff from, or downloading Project Euler problems to my working directory. Such that I have the structure here from the left. All right. So yeah, if anybody is in the chat, please always feel free to ask questions and help out and whatever you wish. Feel at home. So problem number 45. Oh yeah. No idea what happened. Path to root directory is home, Euler or Julia. All right, that one got downloaded into this weird directory. And I can use solution. So it changed the directory immediately. So what we want to do is we want to have this hypernumber, which is triangular pentagonal and hexagonal. So one approach is to probably have a look that the hexagonal numbers are rising the fastest, I believe, which makes sense. So we probably want to iterate over the hexagonal numbers and have a function to check whether it's triangular and whether it's pentagonal. And we have a function is pentagonal already. Oh, and we want to have this discrete function. We want to have both functions. After this one, yeah, triangular. Wait. Triangle number or iterator. We have an iterator for it. But I'm not sure whether we have something like this triangle number. There we go. No, it's not. What if? And then we just I'm getting maybe a little bit fast between those, but I hope you can follow. And besides that, ask questions. Okay, maybe while not found, we start with n equals 1 and not found equals to true. And we have n times hexagonal n equal to 1. What weird thing happened here? I don't know, but I think it will figure it out. If hexagonal, or maybe just call it num, bigger than after, and is pentagonal num, and is triangular num, then not found is false. Or I probably just want to return the number. Yeah, I really don't know what's happening here. Next hypernumber. Oh, it was a weird minus sign. Okay. Okay, maybe we want to just to verify whether it finds the first one. It does. So this is probably the correct solution. And it takes a while, which, as mentioned before, is a good sign. Just remember that what I did before is having this, which might be reasonable. And just to have a test case for it, that makes sense. Let's go to the next one. Yeah, so always go in the chat if you have questions. 46. Besides that, I will just run through them as fast as I can today. If you don't mind. Okay, it was proposed by Christian Goldbach, German pronunciation here, that every odd composite number can be written as the sum of a prime and twice a square. What is the smallest odd composite? Composite numbers is just numbers that are not prime, right? What is the composite number? All right. Yeah, so I want to check. Yeah, okay. Just non-primes. Why are they? Oh, because it's odd. Okay, yeah, that makes sense. Is the sum of a prime. Okay. We have to disprove the conjecture here. Okay, but okay, I think we want to have the primes package. I'm just wondering whether they have. They don't. Okay. Anyway. So let me think about this. So I'm thinking run through all odd numbers. Check if composites. Do we want to have a list of square numbers? Feels odd, but maybe a list of, so I don't know. Go to some points. I don't know. And probably also div that too. Okay, so we go up to 100,000. If is prime, yes. If not, oh, is prime I, and then continue our search. Otherwise, it's composite. Then we want to have list primes up to, and okay, this is a very slow process I'm thinking of, because it's basically in cubed algorithm. So, but for P in list primes, if P bigger than I, break. Otherwise, I minus, if I minus P in this double square numbers, then return I. It's probably a horrible idea. Oh, and it doesn't work. Okay, why doesn't it work? Oh, wait, not in, right? Oh, man. Wait, how do you write that? Probably just like this. Wait. I want to write it differently. Found is false. Found is true. Wait, found is false. Found is true. Break. If not found, return I. And I think 1 is probably not a composite number. Yeah. So 4, 6, 9. You can start with 9. Seems kind of small to me, to be honest. But okay. Do I trust my system? Shall I trust my system? Huh. I thought Goldbach would knew better than that. Okay. It was again easier than expected. Alrighty. The first 2 consecutive numbers to have 2 distinct prime factors are, yes, the first 3 consecutive numbers to have 3 distinct prime factors. Okay, find the first 4 consecutive integers to have 4 distinct prime factors each. Okay, so the 2 is allowed to be there twice, but each of them has to be okay. I think there's, I'm not sure whether this is cheating. Okay, I think that might work. Yeah, okay. Distinct primes. So yeah, by the way, I might be streaming again on my Jarvis project later this week. And Jacob Zalko, aka the Zeta Prince, a fellow Twitch streamer, is probably streaming when I'm done, so in 1.5 hours approximately on it. and I will help out there as well. So if you want to check it out, it's our new Julia project of doing some animations. Where was I? I want to do using primes again. And yeah, I think it's a little bit cheating of using this factor function. But you do what you can, right? Is cheating? No, yeah, probably it is. The normal primes function is okay because we wrote it in one of the early problems to get all prime numbers. But whatever. Feel free to comment whether you think it's okay or not. Nobody will comment. Nobody will comment. So for I in 1, 2, no, I equals to 1, while not found. I can let's do it this way, because I will return anyway, and not do it the correct way, I guess. Found num is 0. So we check is prime I, then make sure to do that. Found nums is equal to 0, I is equal to, and continue. Otherwise, get factor of I factors if len I don't know, call it k. If length of fs equals to k, then found nums plus equal to 1. If found else, I guess we reset that again. If found nums equals to k, then return I minus k plus 1. What is the first of these numbers? Yes. Distinct. Yes. 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 I don't know, maybe. Twitch.tv. Because Project Euler currently can't decide. Let's. Oh yeah, it's correct. Let's make some advertisement for this stream. Okay. And now the next one is probably super hard and people are joining. I will fail horribly. Yeah, this is somehow what I expected. Like, what? Okay. We have this weird series. I want to have the last 10 digits. I mean, I'm can handle it, I guess. But it seems like there is a better way to doing that, but self power. Return last 10 digits of 1 to the 1 power 1 plus. Yes, I can't count. Correct. Okay, this feels very, very stupid. Can I do... Okay. I might have not installed this. Just want to do some benchmarking on it. Because big integers are not the fastest, but currently, so can I focus on... That's also not too bad. What is the last digits? Oh, can I do... What if I do... Let me think. If I want to have the last digits of that, we have 4 to the power 2 is 16, and we have 6 to 6 times 4, and then 4 times 4. What is that? 4 times 4? Is that... Let's call that test. So what I'm thinking about is we want to have I think writing it this way works. Hi there. I'm currently trying to figure out a better way of doing these problems without using big ints. And I'm thinking that I can basically use modulo s. It's not really base, but use modulo b for it. So for j equals that's internal s. Can I do internal s times equal to I, and then oh wait, this should be 0. Maybe here. I don't know whether I have to do it every time. Oh, thanks for the follow. Nine one one 08467. Yep, that looks good to me. What are you up to? Why is this slower? No, that can't be right. I mean, yes, because this is a bad way of doing multiplication. Oh yeah. What are you working on again? On I can't remember. I'm so bad. You told me. Oh yeah, geospatial, exactly. Yeah. Some geo stuff was on my mind. But yeah, I remember. So how's that going? Are you coming forwards? Oh, you want to look into Jawas. Nice. So Jacob is streaming about it after my stream, so in about an hour. Yeah, if you have, I actually wanted to watch the Makey talk from JuliaLang. I haven't yet. I really find it quite weird. Their observable stuff, super odd to me. Haven't figured my head, wrap my head around it. This is more like an experiment. Okay. So next up, the arithmetic sequence. 148748171, in which each of the terms increases by is unusual. Each of the three terms are prime. Each of the four-digit numbers are permutations of one another. There are no arithmetic sequences made up of 1, 2, 3, or 1, 2, or 3-digit primes. Exhibiting this property, but yeah, okay. What 12-digit number do you form? Oh, one other 4-digit increasing sequence. Okay. Probably I start with the smallest one, right? Okay. Doesn't seem too complicated when I'm allowed to use the prime list. So function prime. Can check how somehow is permutation. Is there a function for it? No, I will write. So yeah, on the Java side, we created some milestones today earlier. He will finish up his grid animation stuff in his stream, I guess. And I'm not sure what I will work on next, to be honest. Why I was going black. Check if M is a permutation. We probably transpose matrix. You can work on that. We tagged it as help wanted. So yeah, I'm still not sure what's the best way to animate it. Like, do you have somehow a concept in mind of? Oh, you want to do it with Manum first? Okay. Do they have stuff like that built in? So yeah, I'm thinking either like flipping the matrix, just like that in like a 3D flip way. I don't know. Or like have all the elements of the matrix, and then like reorder them, just moving the ones which changed. Yeah, I'm not too sure about that. So you think the reordering, just moving, like have the diagonal fixed and move the other ones over? Okay, then we would have to render the LaTeX or figure out which are the elements, or like the elements of the matrix. Figure out where they are. Like we would need to have a mapping first of where the elements in the matrix go. What is the corresponding one? kinda. It's hard when you don't do that LaTeX yourself. Well, that would be even harder, but yeah, I'm not too sure about that. It's in my mind. Extradict. That sounds like a fun function. How can we? That's good. Okay. We have a dictionary which takes in an int and also an int, like the number of points. Dictionary is much better. And then we want for int, we want to have a plus equal to 1, return a. So is permutate 14874817. Oh man. Might want to fix that, shall we? Okay. Oh, and we want to oh, they are 4-digit ones, so it shouldn't be too hard. Okay. Whatever we are doing, we don't need all of it, but if is prime I, oh. Somehow a weird problem. Now we really want this thing, or are we only concerned about prime and because this one is I don't know. I don't really get the question, I suppose. Probably this is a variable as well, otherwise it doesn't make sense, I guess. And what else do we want to have? Oh, okay. But they are not permutations of one another. Wait. Oh, don't have this. Okay, maybe I want to write it down. I don't need to think about stuff like this. Okay. Two, 9, 6, 9. Okay. That could work. 2, 9, 6, 9. 6, 2, 9, 9, 9, 6, 2, 9. Sometimes they are too simple. Such that I think this is a very naive solution. It's like, yeah, and I don't know. It's weird. The prime 41 can be written as the sum of 6 consecutive primes. This is the longest sum of consecutive primes that adds to a prime below 1. The longest sum of consecutive primes below 1000 that adds to a prime contains 21 terms and is equal to 953. Which prime below 1 million can be written as the sum of the most consecutive primes? Okay. 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 Um, 2, 2, 3, 2, 3. Hi, Melissa. It's similar, kind of. They're a little bit, so it is open source. It's fast, which is not MATLAB. But they are targeted to mathematics. So they have similarities, I would say. Do you have any special questions? I have to say that I'm not, I don't know much about MATLAB. I used it once. Okay. If you only use calculator, then I don't know. I like the syntax of Julia because you can you can use Unicode characters, so you can use pi. You can work with pi. You can use alpha if you are working with some angle or whatever. I don't know the power syntax in MATLAB, but it's so you can write 2 to the power 2 instead of the Python way, which is this one, which is annoying, I think. Yeah, I don't know what you use, but yeah, give it a go. And I just prefer it because it's free, it's open. Yeah. I think, well, because they are both Turing complete, every language kind of is. You can always find a way. I just find Julia really simple to use. Consecutive primers. Okay. So I want to. Oh, I don't know the number. Okay. Oh, and I don't know the starting size. I'm just a little bit thinking about it. So what we can do is basically this is our start prime. And then we have just this. And then S is equal to prime list of J if S yeah, I think that makes sense. So if S is equal to I, then we found one. Print found which can be written as $J primes as sum of J. If S greater than I, break. Do you have any other questions about Julia, Melissa? Okay. Okay. If I also want to have if oh no, wait. What do I want to do? I want to check if this is the prime. Okay, I might want to have below 100 just to check whether that makes sense. 41 can be written as 13 primes, and 43 can be written as the sum of 14 primes, and all just counting upwards. That seems not correct. Oh, wait. Oh no, I want to have $J minus I plus 1, I guess. Okay. So I have, starting with this start prime, let's have this. Okay, so prime, yes, start prime 3. Okay, I might want to go to 42. 41. Start prime 2. Oh no, start prime, actually this. Okay, that was the error. Okay, so 41 can be written as, now we want to go to 1000 and we want to have 953 can be written as the sum of 21 terms. Yes. Okay. So first of all, and I don't need that. I want to get rid of them. Okay. Longest chain is the one. If chain length bigger than longest chain, okay, 1, 2, 3. This is actually taking time. That's nice. Okay. Let's check that. And then also make sure flawless 50. Okay, let's make it fast. So the problem is let's go maybe back to 100 or something. And maybe have that. Okay. I am thinking about, we currently start with the smallest one, right? And if that one is bigger, so we start with 2, 3, whatever. If that one is bigger, we might want to reduce it by subtracting 2 from it, and then subtracting 3, and so on. If that makes sense. I think it does make sense. Let's have that one again. I think that's getting close to, sorry, to a minute. Okay. Let's have start prime. Oh, the first prime. What was my solution again? 997. Okay. This one is way faster, but it's wrong. So for what we can do is so we have this sum, yes, and we want to subtract okay, no, we still have the J working for us. Okay, so, but we have added. Okay, so we want to, no, we want to have added. We want to have S. So we want to have for S minus prime list. Okay. If S equals P, then chain len minus K, I guess. Okay, this is odd. Oh. Back to business. Okay. So otherwise, if we are smaller, we might want to this is weird. Okay, wait. What happens? Oh, good. Oh, sorry. Sorry. If that is bigger than break. Okay, that was making sense. The problem is yes. Okay, when we are there, but we are not there. This is getting a little bit messy. I know we solved that problem already, but okay. I think it's getting into an infinite loop now. Yes, I get it. Okay, so oh, but maybe we're getting here, but we are not getting there, which is a bit odd. Okay, but maybe it's 1. Okay. At that point, if it's true, we want to break, and we want to set I to length of prime list. Yes. Okay. Okay. Yes. This is then kind of the same speed. Hey, Katie. We solved the problem already, but it's too slow. So I want to make it faster. And it's probably a mess to read. So let me take the time to explain it to the stream again. So I'm trying to find the prime number below 1 million, which can be written as the longest sum of consecutive primes. So the idea is I loop over all primes below 1 million, and then the mess starts. So the general idea was first do 2 plus 3 plus 5 plus 7 plus and so on. And if it's bigger, just get rid of it. And if it's the same, take it. And if it's bigger, we start with 3 plus 5 plus 7. So the problem is we sum a lot of, well, we do a lot of summations more than once. So the next idea below here was basically instead of, so when we are over, we can remove digits from the left. But then when we are under it again, we should start adding digits from the right. And this is where I'm currently messing things up. Because at that point I started again with the naive approach, which is stupid. Okay, so you say it like it's actually a good approach. But yeah, I think what I'm doing is kind of the idea for the ends is okay, but my approach is not well defined. So I am thinking about maybe having another function which takes in basically a start and an endpoint of so when we are over, we would call this function, which I don't know how to name, which takes in the starts and the ends and removes and a list of primes, and then as well as the prime that it wants to reach, try to find prime. So it takes in starts, basically left, right, prime list, and the prime itself. Oh, and the sum. Okay, so basically if, and this should go there, try to find prime, which takes the sum, left is 1, right is j, prime list in P. And if S is bigger than P, which we have here as well, so yeah, I don't know, then, or maybe if S is equal to P, then return thinking about doing it recursive right now. If S is bigger than P, is basically while S is bigger than P, we have S minus prime list of left, and left is going up. And then okay, maybe this one is a little bit weird. So do I ever think I don't. Well, okay. If S is equal to P, then return R minus L plus 1. And if, while S smaller than P, S plus prime list R plus 1, yes, return, try to find prime of S, L, R, prime list P. This seems so weird. Okay, and also where do I get that error actually? Right here. L bigger than prime list, return 0. Length of prime list. This is a very hacky, weird way. Okay, let me maybe start recursion with $s. $p. Oh, okay. Okay, if prime list L is bigger than P, we can also return 0. Wait, what? Oh, wait. Do I want that? Okay, somehow. So I actually haven't saved the correct solution, like or like the primes for it, or the starting prime. Just okay, J is not defined there. Okay, we don't even get the 9531, which is interesting. Okay, then let's go to this. Okay, and then okay, 963. How about here? Nine five three. 4 to 25. Oh, I don't. Wait. This is, of course, chain. One primes. So why? Oh, because we are adding one there anyway. I think I might want to actually do that. Not too sure about that. Okay, wait. I'm not sure whether this is correct, but it is correct so far. Hmm. I don't really get where this is coming from now. filling the tree. I don't know how this can cause recursion. I thought I was always changing L up and R up. Problem is, when is the recursion happening? I don't change the P, I don't change the prime list. Change the S. Well, that should be okay. Okay. I think I know a way to speed this up, but wait, what? I'm not going into recursion hell anymore? This is super weird, but okay. Well, wait. What I was thinking is we actually have this longest chain stuff, and if R minus L plus 1 smaller than longest chain, then return -1 as I don't care, and we're done. Okay. This is the main point. Yeah, because sometimes we're just getting closer and closer to the actual prime, and then we have a chain of 1. But we don't care about a chain of 1. So this seems fine. All right, and it's almost 2 hours. So let's thank my patrons for supporting me again, and everybody who watched the stream. As some of you might know, I'm normally more blogging about a new project called Jarvis. Hi, I didn't know you were here, or did you just join? Yeah, we did 2 hours, so maybe you just joined recently. If that's the case, you might want to check out the next stream by Jacob, who I will ask whether I should rate him half an hour ago. Yeah, so thanks everybody for watching. We did 45, 46, 47, 48, 49, and 50, I think. Yeah, 50 is the latest. So we did 6 one, if I count correctly. 6. So we are halfway done. That's quite nice. All of them were solved relatively quickly. Just the last one was a little bit hassle to make it quick. But yeah, anyway, I brought on opensource.es with us, which is not open source with an e.es. Just one e. I know it's a horrible name. Oh yeah, by the way, what I wanted to show you is I have stickers now for my constraint solver logo. So one of them is on my laptop, which I try to show you there. So yeah, that's what I do with your money. No. No, it was $1. Oh, really? Java setup prints is streaming now. No, that was for Julia conference. There was one to get 10 for $1, whatever sticker you like. And I used my own square stickers instead of the Julia sticker, which would not fit well to a square one, I guess. So I took the chance. Anyway, see you maybe later this week for another stream on Jawas. I will rate you to a stream on Jawas right now. And thanks also for the intro music, which was really I had problems with my stream again. So probably you missed it again. Sorry about that. Anyways, thanks for joining and see you next one, guys.